So let me introduce you the next session. It's about enterprise, campus, and branches, no carriers, so entirely enterprise here. We had Matt Davey from Indiana University as a speaker, and he's been running one of the biggest campus out there and one of the most complex one, as well as Steve Brar from Hewlett-Packard from HP on the networking side. So I give them the floor.
All right. Thank you, Isabel, and good afternoon, everyone. My name is Steve Brar. I work in the product marketing group within HP Networking. I'm responsible for OpenFlow marketing as well as software-defined networking marketing for the network group. I'm also responsible for marketing our modular and chassis-based switch platforms for both campus and data center networks. I have a product management and software engineering background. A little bit about HP Networking. We're the #2 enterprise networking vendor. And you may or may not already know that we have a pretty broad commercial availability of OpenFlow support on our portfolio, 16 different models of switches. I'll be co-presenting today with Matt Davey from Indiana University, who is Indiana University is a longtime HP customer and HP networking customer. He'll talk a little bit about Indiana University's environment, the complexity in their network, as well as go through several use cases and interesting use cases that I use deploying using OpenFlow today in their network. In addition, he's also the executive director of InCenter, which is basically an interoperability lab for SDN and OpenFlow. They do network research as well as internships and training. So in terms of objectives for the session, similar to some of the other sessions, I want to give you guys a good understanding of some of the trends and challenges facing enterprise campus networks today, as well as talk about some of the ways that OpenFlow and SDN fit within the enterprise network. And then we can discuss some use cases and associated benefits. Now, I know you guys sat through several different sessions today, so I'm hoping everyone has a pretty thorough and strong understanding of OpenFlow as a technology, the protocol itself, and how it relates to software-defined networking. So in this session, we'll focus primarily on how it fits within the enterprise and the enterprise use cases. There's been a lot of buzz in the industry around OpenFlow and SDN, and a lot of it's focused around service providers and data centers, and academic and research communities. So you may wonder, what's this applicability in enterprise campus environments or branch environments? And you may ask, is it even relevant? And really the answer to that is it is relevant, and it will be relevant, and it's going to do some of the same things that it's going to do in those other environments in terms of transforming the network. Some of the benefits that you'll see with OpenFlow in the campus environment are similar to some of the benefits we've talked about in service providers and data centers in terms of better utilization of resources, increasing simplicity, management simplicity. In addition, OpenFlow is ideal for addressing some of the new challenges that enterprise campuses are facing. In terms of market opportunity, I really didn't take, the challenge of trying to define what the TAM would be in the enterprise market space. But if you think about the sheer install base of enterprises, and enterprises really being the entry point into the network and the data center, cloud, private cloud, enterprise cloud, there's a lot of equipment out there that could potentially increase the market opportunity for SDN type technologies. There's also new markets like control software. Some of the presenters talked about applications and apps. So it's really hard at this stage to really judge how big the opportunity can get. If you look at some like smartphones, for example, several years ago when apps and these types of things started first being discussed, it would have been really hard to measure how big that market would get. And just last week we see a single smartphone app company being sold for $1 billion. So I think there's a lot of potential in the networking space as well for those types of applications. It may not be as large as the smartphone opportunity or have the number of applications, but definitely there's an opportunity there for increasing innovation and increasing that market. So in terms of looking at the challenges facing enterprise campuses today, really a lot of the change is being driven by video and mobility, or media-rich applications, mobile devices, wireless. We're seeing the need for increase in bandwidth requirements primarily being driven by these high bandwidth applications such as multimedia and video. And really what we need to do is, oh sorry, I forgot to advance the slides for a while. We need to look at the architecture of the network, and we need to look at how we can better utilize it in order to meet these needs. Not only do we need bigger pipes in terms of network switching infrastructure, moving from 10100 to gig, 1 gig to 10 gig, but we also need to look at how to better utilize that infrastructure, and that's something that SDN and OpenFlow can help us with. So the other aspect is the sheer number of devices that are being introduced into enterprise campus. By the year 2020, there will be at least 50 billion wireless devices connecting to the networks. And some of the things that people are looking at is how to better unify wired and wireless. We need to look at how to deliver a consistent experience across both of those realms to applications. People are, like BYOD, bringing own device. They need to be able to access the network with any device from any location at any time. And in order to do this, we're going to have to look at more ways of making the network dynamic, and that's where SDN and OpenFlow come in. And then in terms of business communications, 25% of all daily business communications will be video or multimedia by 2013. And really, this is a critical thing for businesses in terms of maintaining productivity, increasing collaboration. These type of applications are very delay sensitive and require reliability in order to achieve the productivity goals. So OpenFlow is a technology, and SDN can help address some of these challenges. So I talked a little bit about delivering a consistent experience. One of the challenges facing the networks today is just unpredictable performance. Inconsistent user experiences across wired and wireless realms. Just this morning we were in here and we had some problems with the wireless network getting on. That really shouldn't be happening in terms of today's technologies. We have the technology to avoid those types of situations, and perhaps with more programmability and a network that's more dynamic and able to respond, we can avoid situations like that. And when it comes to the branch office, if you look at the branch office, it has some unique challenges in that users in the branch are expecting the same type of experience you have in the campus. And they may have other limitations in terms of WAN connectivity, in terms of limited IT resources on site. But really with the move with all these applications into the network, it's necessary to give them an equivalent experience. The other aspect that is becoming more challenging in enterprise campus environments is just the management of the network infrastructure, what I like to call swivel chair IT management. If you look at the way networks in the enterprise are being managed today, you have a lot of different management interfaces on a lot of different devices. It's all distributed. You have scripting, you have CLI, in some cases you're using SNMP. And so it's a very distributed method of management, and it's not very efficient. Network management tools have come in and are helping move the bar forward in that respect, but it's still, an overlay onto these traditional interfaces. And then in terms of the architecture of today's campus networks, with the way they're configured logically, they're very static and unable to be agile enough and dynamic enough to adjust to changing needs on the network. A lot of these configurations are set and forget. Once you configure these different protocols and things to handle the various applications, you're expecting them to perform as required. They don't adjust dynamically. So that limited agility is really hindering what today's campus networks can do. The fourth aspect really that's challenging today is ensuring privacy, ensuring availability and security of the network. Campuses and enterprises are facing more challenges around ensuring compliance with various regulations, ensuring that services are available all the time. And security is an interesting one. It's a challenge and a balance between providing usability for the users and then still offering the right level of security. So it's always a balancing act between how difficult you want to make it for people to access services versus ensuring and maintaining a high level of security. So I wanted to just go through some basic requirements of what enterprise networks are facing today and what types of things they have to deal with. So in terms of users is a big deal, right? Users, the number of users, where they're accessing from geographically, and giving them the right policies and access rights is something that network administrators have to worry about. And it's becoming more and more complex to configure these things and provide the right level of access when necessary. From an application standpoint, there's more and more applications on the networks, different types of applications with different requirements, whether it's a business application, a productivity application, unified communications applications, backup. They all have different requirements, and they all need to be supported by the network. I think Rakesh or Amit had talked about kind of a black box environment, and that's what network administrators have to deal with today. They don't know what necessarily is going to come into the network, but they have to design the network in order to handle that. From a device standpoint, there are more devices than ever connecting to the network, different types, smartphones, tablets, thin clients, printers, PCs, cameras. They all have a lot of different requirements. They require different type of quality of service. They may need isolated VLAN or something for that type of traffic, different access rights. All of this is creating a lot of complexity in configuring and managing the enterprise network. So, with the increased dependency on the network to deliver all of these applications, the users access the applications, it's important to provide a high level of redundancy, a high level of availability at all the network layers. And that's one of the challenges that network administrators are facing today. So here I wanted to provide just a basic sample kind of infrastructure that you see today in today's campuses. Obviously there's a lot of variations in how people deploy things in terms of resiliency and reliability and redundancy. But here we have a traditional 3-tier kind of campus network that has some WAN connectivity out to the data center and cloud. And you can see that not only is there a physical infrastructure there that needs to be managed, but we've created this logical infrastructure using protocols like VLANs, various routing protocols, multicast, QoS. So it's created a lot of complexity, and there's 2 layers of infrastructure that really need to be managed. So with OpenFlow, when you introduce OpenFlow, and really that's being introduced on all the devices that make forwarding decisions. So if you look at your wireless APs, your access layer switches, aggregation or core layer switches, routers, that's where you're going to be implementing the OpenFlow protocol. You're going to see vendors implementing it there. And that's going to help bring out that programmability aspect into those components. So HP, for example, we've implemented OpenFlow on several models of our switches in parallel with the existing OS. So customers can adopt OpenFlow for various use cases while still maintaining their traditional logical infrastructure like VLANs, etc., without interruption. The other thing OpenFlow can do is it can interact with various appliances like firewall, IDS, IPS, wireless controllers that already exist. In fact, wireless controllers are similar in concept to how OpenFlow would work, but OpenFlow provides that open interface and more direct access to the forwarding plane. For example, you could take traffic coming into the router, and the OpenFlow controller could match that traffic or not match it and decide what to do in terms of forwarding it over to a firewall, IDS, or IPS. Some of that functionality in some of these appliances may be pulled into the controller, or control software. It's not necessarily a single box, the controller. It could be a set of controllers or control software on a server. So that's just a representation there. But you can see some of the functionality pulled in, but there'll probably be still some functionality that's going to require some level of hardware acceleration. So these devices are still going to be important to have in the network for depending on what the requirements are. So in terms of use cases, I want to talk about 3 use cases for Enterprise Campus. These aren't all encompassing. Obviously, there are many other use cases. Some of these are similar to the ones you've heard for the other environments. The first one is management simplification. And before I talk about network virtualization, I just want to talk about some of the various ways that, more incremental ways and using hybrid OpenFlow switches that you can use in order to implement some management simplification. One example I'll give is a demo that HP has been doing at various trade shows, and we'll have it here at the expo if you guys want to take a look at it. It's basically an identity-driven QoS controller, and what it does is it will look at whatever user's logging into the network, and it'll assign the appropriate policies and for quality of service to that user for various applications dynamically. So this is taking out the aspect of statically configuring QoS policies on the actual devices and pulling that out into some control software so you get more programmability. The flows are set up dynamically. You don't have a static QoS policy on the device. So it's these incremental use cases depending on applications and stuff that are going to be compelling for some customers. When you start talking about network virtualization, that's really moving almost all of the functionality out of the devices and into some control software. So you have and you really need OpenFlow support on almost all of the infrastructure devices in order to achieve this, to have a global view where you can really start looking at the network in a different way. You don't have to rely on CLI configs or SNMP. You can look at it in terms of applications and users, and really provision and policy your network based on those aspects and kind of forget about the underlying physical infrastructure. And one of the benefits of OpenFlow, I mean, people may look at other protocols and scripting and things like that as a viable solution for achieving some of this programmability. And while that's true, OpenFlow provides differentiation in that it's an open standards-based protocol, and it can be implemented on a multi-vendor hardware. So regardless of, you don't have to go with one single infrastructure vendor in order to realize the benefits of network virtualization when you look at OpenFlow. So in terms of another use case is security. And really when I look at network security, I mean, there's a plethora of protocols out there today, 802.1x, you can look at appliances, firewalls, IDS, IPS, that are all out there to provide, increased security on the network. So with OpenFlow, I see it as providing a more granular ability to manage security, whereas today's protocols and things are static in some respects and may not be as programmable. So if you look at an example of bring your own device, like iPhones, tablets, and you want to apply different security policies for different devices, there are a variety of fingerprinting methods available today for identifying what the device is and what policy, and then you can apply whatever policies are necessary. The challenge is none of those methods are perfect and they're very static. With OpenFlow and the programmability aspect, you have a lot more flexibility and extensibility in determining how to deal with various devices coming on the network. You can look at a lot of different information and essentially create a better fingerprinting method for these types of devices. The other thing it can help with is providing a more consistent policy enforcement across different domains like wired and wireless networks. Ultimately, I think the programmability aspects will lead to improved security on the network while still allowing ease of access for users. And then the third use case I wanted to talk about, and Amit touched on this a bit as well, was application-driven networks. And I think this is really the most exciting use case. Well, network virtualization is as well, but application-driven networks really have the ability to, transform the way we think about the network and applications and the network stack and how they interact with the network. If you look at, some sample applications like backup, for example, in the enterprise, if I want to back up a device, a backup application could talk to a network controller who has that global view and determine, hey, I'm going to transfer, 40 gigabytes of data, and the controller could tell it, well, the network is at a high utilization right now, we'll do that later. And it can be this dynamic interaction where you have better utilization of the resources at the right time. Another example, kind of in the opposite direction, is if you look at emergency services like 911 and things like that. If you have that type of activity on the network, you can dynamically provision the path through the network with appropriate quality of service, etc. If that application, like IP phone or whatnot, can talk to the controller and let it know, what it needs and what it's requesting.